Hello guys, this video I will talk about difference between bias and confounders. This is a follow-up video of my previous video on confounder. So watching that video will be helpful. Here I have a research study by researcher A where he collected data like this to test his research question that does coffee drinking increases heart disease. Relative risk of heart disease is 2.12 with coffee consumption. This is the same data, but here the independent variable is categorized by age. After adjusting for age, researchers found that age-adjusted relative risk is approximately 1. Now, the second researcher also wants to test the same hypothesis. Does coffee drinking increases heart disease? For that, he collects 1,000 coffee drinker and 1,000 non-coffee drinker, but he collects coffee drinker only from elderly age groups, that is more than 60 years, and non-coffee drinker only from younger age groups, that is below 60 years. He calculates the relative risks of heart disease and found that relative risk of heart disease with coffee consumptions is 4. If we look closely, we see that first researcher found high relative risks because of confounder, and second researcher found higher relative risks because of selection bias. The selection bias by a second researcher is more specifically known as differential selection bias because the two groups, coffee drinker and non-coffee drinker, are not similar to begin with. When we go to study by a researcher A, you may think that he also selected the two samples, coffee drinker and non-coffee drinker, differently for two groups. Let's check that. Finally, a third researcher enters the scene. He collects data from whole of the populations. He did a hard work and found the result from the whole populations. His result was as below. The total population was 1 lakh. The total number with age more than 60 was 20,000. And the total number of coffee drinker was 12,000. When researcher A selected 1,000 coffee drinker, his selection had 66% of people more than 60 years of age. We see that the coffee drinker in a research study by A with a populations above age 60 was 333 plus 333, which makes 666. That is 66% of the total coffee drinker. The proportion of people with age 60 who are coffee drinker is same in the whole population if you see here. There are total 12,000 coffee drinker and 66.6% are age above 60. So the distribution of coffee drinker was similar in the total population and the sampling by research study by researcher A. The proportion of people with age more than 60 who had heart disease in research study by A was 50%. You see that in a research study by A for both coffee drinker and non-coffee drinker, 50% of the people with age more than 60 have a heart disease. When we look at the total populations, we see that people with age more than 60 years have heart disease 50% of the time and don't have heart disease 50% of the time. Hence, the distribution is similar. The proportion of people with age more than 60 who had heart disease in total population was also 50%. Lastly, when researchers selected the 1,000 non-coffee drinker, we see that total 68 plus 68, which makes 136, that is 13.6%, were of age more than 60 years. If we look at non-coffee drinker from the total population, we see that 13.6% are above age more than 60, which is similar in the sampling by researcher A. Hence, we saw that researcher A selected the sample that represented the whole populations. He did not select the two samples with bias because the sample proportion represents the population proportion. But researcher B selected two samples differently, resulting in selection bias, more specifically, differential selection bias. Although many considers confounder also is bias, but confounder are different from observation bias and selection bias. Bias is an error, but confounding is not an error. Bias cannot be accounted during data analysis, but confounding can be accounted during data analysis. Thank you, like and subscribe.